Yeah, hello. Hello. Oh, yeah. Yeah. Basically, we were doing the angle bisector theorem, and this is what I told that if you have an internal angle bisector, you have to prove that. Rushil, I'm in a class, yeah. Hello. Yes. Yeah, I'm in a class. I'm doing it. You please be there. You take see the messages there in the group. You'll get the information. So see, I'm in the middle of this thing. How can I answer your queries now? Right now, tell me. You check the messages in the group. Okay, check the messages in the group. Yeah. So basically, yes. So basically, what I was saying is this is A, B, C, D, and I told you that extend BA to E, and then you join EC. And what is the condition here? You have to make sure that AE is equal to AE is equal to EC. AE is equal to AC. That is what we have done the construction like now. So basically, it is given that this angle is equal to this angle. So let's say this is X. So this is also X, and we just said that AE is equal to AC, and we join EC. Okay. Now, what next? So basically, now if you see that AE is equal to EC, we can say that this angle will be equal to this angle. Let's say this is Y. This is Y. Why? Because both are opposite angles to opposite sides in a isosceles triangle. Y. Correct. Now, what next? If you see, also if you see, in I can write angle BAC is angle Y plus Y. Why? Because it is exterior angle is equal to sum of interior opposite opposite angles. This is from our ninth grade knowledge. So BAC, and what is BAC? If you see, this is 2x is equal to now 2y. So hence I say x equals y. So x equals y. That means this angle, if you see, is equal to this angle. This angle is equal to this. So I am marking it, or let's say, let me mark it with blue color. So this angle is equal to this angle. Now, what does this mean? The moment I say that, it becomes what is the inference? So if x equals to y, we can say that AD is equal to AD is parallel to CE. Why is that? AD is parallel to CE, and why is that? Because interior, and we say this is in corresponding angles. Corresponding angles. corresponding angle. So hence, if AD is equal to CE, AD is parallel to CE, then again I can in triangle A, sorry, B, E, C, I can use BPT. In triangle BEC, I can use BPT and say BD upon DC. Let me again take this picture here so that it is with you. Okay, so yeah, so then I can say, take this, yeah, so I'll paste it here. So now if you see, I'll paste it here. Yeah, so if you see BD by DC, this is B, this is B, this is my, this is B, this is B, so B. So BD upon DC is equal to BA upon AE, and this is because of basic proportionality theorem. Why? Because AD is parallel to EC. Now, if you see AE was equal to AC by construction, so I can say BD by DC is equal to BA, this BA by AC. Why? Because by construction AE is equal to AC. AE is equal to AC. So hence this is what we had to prove. So BD by DC is equal to BA by AC or AB by AC. This is angle bisector theorem. Now I'm not going to the external angle theorem here. You can prove it by the same method. So this was the first thing, which is first set of theorems. So quick recap, you have to remember, first is BPT or the Thales theorem. Then second is converse of BPT, converse of BPT. Third one is we learned midpoint theorem. Fourth, what did we learn? We learned angle bisector theorem. Angle bisector theorem. So please remember these theorems and always keep them in mind whenever you are solving problems. Now let's move on to the concept of similarity. And we know that similarity, two criteria were there for similarity. Similarity of any geometric figure, figures. What are the criteria? Right. First is corresponding. I am assuming you know what does corresponding mean. Corresponding angles are equal, and second criteria is corresponding sides are proportional. These are the two basic criteria for any similarity of how angle BAC is equal to y plus y. There is a question for the previous section, Anand. The question BAC. So BAC, if you draw this, let us draw only AEC. So this is E, this angle is E, this angle is C, this is A, and let's say extend this to B. So if you see, this angle is 2x, this is external to y plus y. So y plus y will be equal to 2x. Y angle, exterior angle is sum of interior opposite angles. Hence, I use that. I hope this query is resolved. Okay. Now coming back to similarity. So similarity of any geometric figure requires two criteria to be fulfilled. Corresponding angles are equal and corresponding sides are proportional. Now you do not, for triangles you do not need to check. So basically in two triangles are there basically. So there are 6 elements of these two triangles. Let's say 6 elements means there are 3 angles. Three angles ABC and ABC. Let's say ABC, and let's say DEF. There are three angles in the two triangles. There are three in the two triangles, and there are three sides: AB, BC, CA. And you know that in ninth class, or for that matter earlier also, you learned that we denote sides by small letters. A, B, C are the letters, and here this is D, this is E, and this is F. This is F. Yeah, Harshit. Yes. Yeah, it's going on YouTube. Please carry on. Yeah. Yeah. So now, so basically, what was the criteria? So we said that angle A. This is what is meant by correspondence. So angle A must be equal to angle D. Angle B must be equal to angle E, and angle C must be equal to angle F. This is one. And then secondly, we said sides should be proportional. Should be proportional. That means AB by DE should be equal to BC by EF should be equal to CA by FD. Right? So these two criteria must be fulfilled. For the two triangles to be similar. Now, for triangles, you don't need all the 6 criteria to be fulfilled. Okay, so and why is that? Because they are, if let's say a few of them are fulfilled, they are good enough, or they are, let's say, sufficient enough to say that all others are also fulfilled. So hence we then find out that if and then we figured out that if, let's say, all the 3 corresponding angles are same, then it is, it can be proved that sides would be proportional. So basically, we then zero down to some of the criteria of similarity. So what criteria should we check for similarities? So first criteria was, let's say, A, and we say angle similarity. Means what? If the corresponding angles, all the 3 angles of two triangles are equal, then they are said to be, or they are called similar, or they are similar. And how do we prove that? So let's see. Proofs would not be there in your board exams mostly, but I'll just try and do one for you, and rest all you can do back at home. So let's say if I have to prove that angle A is angle B and angle C are correspondingly equal to D, E, and F, then the two triangles are similar. How and what should we do? So let us do this. What I'm trying to do is, so let us say that there are 2 different triangles. That means, and we say that none of the sides are equal. So let us assume that AB is less than ED. Okay, AB is less than ED. So we can definitely pick up one point E dash here, such that AB is equal to DE dash. Okay. Similarly, I can pick up a point F dash here, such that what will happen? DF dash is equal to, I'm constructing such that DF dash is equal to, let's say, AC. Okay, and join E dash F dash, join them. Okay, now let's consider 2 triangles, triangle ABC and triangle D, E dash F dash. Okay, now clearly by construction we saw that AB is equal to DE dash. They are equal. Then we said AC is also equal to DF dash, and by and it was given that angle A is equal to angle D. Now in our 9th grade previous year, we had studied that this is nothing but SAS congruence criteria. So by SAS, I can say that triangle ABC is congruent to triangle DE dash F dash, and hence I can say that BC is now equal to E dash F dash, and I am marking these angles as well. So this angle is equal to this angle, is equal to this angle, and this angle is equal to this angle. This angle is equal to this angle because of CPCT, and this angle was given to be equal to F. So all these three angles are equal. So if you see, angle F dash becomes equal to angle F, angle E dash becomes angle E, angle E. That means you can now infer from here. What do we infer from here? E dash F dash E dash E dash F dash is is parallel to EF. And the moment you said that this must strike, right? What is the thing now here? Let's say if the E dash F dash is parallel to EF, that means now one thing which strikes my mind is use of BPT. So the moment I saw a parallel line, I can use a BPT, and then I can say DE dash by DE, it's actually the corollary to BPT, is equal to DF dash by DF. And since DE dash was equal to AB by construction, this side, this much is equal to this much, I can replace that there, and I can say, what can I say? I can say DE dash, instead of DE dash, I can say AB by DE, AB by DE is equal to AC by DF. And this exercise can be repeated 3 times to prove that all the corresponding sides are proportional. So what did we get? The 3 angles were same. And what did I say? That if you can prove it for one pair of sides, you can again do it. What you need to do is now you have to pick up a point here such that this is B dash, and pick up a point here such that it is A dash, and connect them, and again repeat the exercise. You will get all the 3 sides proportional. Yeah. So this particular exercise can be repeated, and now we what did we get from here? The three angles were anyways given to be equal, and from this proof we just proved that the sides are also proportional. So we can say that the 2 criteria for the similarity are fulfilled, and hence the two triangles are similar by AAA similarity criteria. Now, the direct corollary to this would be by angle sum property of a triangle, the sum of three angles in a triangle is 180 degrees, right? It's constant. That is, it is a constant. So instead of checking 3 angles, even if you check the 2 angles, only 2 angles, the third automatically will be equal. Why? Because the sum of the 3 angles is nothing but 180 degrees. So hence, it is reduced to, now it is simplified only to check only 2 triangles. So meaning, what is the meaning? Meaning is, if 2 corresponding angles of 2 given triangles are same, that is equal, that means the triangles are similar. Similarly, the other similarity criteria, so this was criteria number 2. Criteria number 3 was SSS, where the 3 corresponding sides are proportional. If 3 corresponding sides are proportional, then the two triangles are similar. This is another criteria. Fourth criteria is SAS. Now you know it already. Side, angle, side. That means, so be careful in this case. You have to take the included angle and not just any angle. So when I say included angle, which I mean is for that matter, what I mean is, if ABC is 2 triangles, and let's say this is another one. Let's say PQR is another triangle, and let's say AB is to PQ. AB by PQ, let's say AB by PQ is equal to AC by PR. Let's say this is given, and this angle, included angle. So please make sure that the angle theta is included angle between the 2 sides. Only then you can say that you can use this similarity. similarity property. Otherwise, you cannot. You cannot say that AB is equal to AB by PQ is equal to AC by PR, and you take this angle. No, this angle you cannot take. This angle is since because this angle is not included, so hence you cannot take that. So always be careful. You have to take the included angle only. Fifth one is ASA, and ASA is actually not required because it's anyways the moment you say ASA, it's like saying AA. So two angles are same, that means they are same. So these many criteria are there to prove any two triangles to be similar. Then moving on, then we have a lot of problems related to, let's say, similarity, and then you have to in the questions would be comprising of two triangles would be given, and some information would be there, some construction would be already given, and you have to prove using similarity some ratios. And I told you, whenever you see questions like PQ square is equal to PR into RS of this form, some of this form. So always remember that this is nothing but they are inviting you to use similarity. Yeah, or whenever there are ratios of sides involved, sides involved. So you now know whenever they're in the problem, they say that, okay, prove that X by Y is equal to U by V or things like that, then you must use, you must be kind of attentive, or let's say you must be using somewhere similarity of triangle. So these are the tricks how to pick up which particular concept would be used. Further in this chapter, there were a few more theorems which I'll just recap so that you are familiar with them. And one was your ratios of the areas. So the theorem goes like that ratios of areas of two similar triangles, ratio of is equal to ratio of squares of the corresponding sides. What do I mean? Let's say if you have triangle ABC similar to triangle, let's say PQR, then area of triangle ABC upon area of triangle PQR is equal to AB square by PQ square, which will again equal to BC square by QR square, which is again equal to CA square by RP square. This you please remember. I'm not going into the proof right now because we are revising it. If time permits, we'll do that as well. And then the last part, which was very important, crucial, was Pythagoras theorem. Pythagoras' theorem. Pythagoras theorem, which you know since your childhood, that if in a right angle triangle ABC, AC square, if this is right angle, so AC square is equal to AB square plus BC square. AB square plus BC square. Fair enough. So this is about Pythagoras, and then you used a lot of application of Pythagoras theorem. We'll talk about little later application of Pythagoras theorem. Application of Pythagoras theorem, and there was a proof was also based on similarity. Okay, so I'll just stop here because I have another this thing to catch up. And what I'll do is, again, let us meet again once again, and let us fix up a schedule, maybe on Saturday evening or Sunday evenings. We'll let you know, and we'll try to have another live session like this and try to revise as much as possible. If you have anything to share, you can always put it in the comment section, and keep do subscribe to the channel so that you get all the information there. And we will keep on posting such live sessions again and again. So looking forward to meet you once again, guys. Thanks a lot for your time, and enjoy your the weekend there. So you have exams coming on from next week, so let's focus on that. Okay, thanks a lot. So I am signing off. Thank you.